We're going to take a look at frequency tables and histograms. So first thing we're going to talk about is a bunch of definitions again, like we've been doing. So the first thing we have here is we have a frequency table, and a frequency table is a table that groups a set of data values in intervals and shows the frequency for each interval. And I've got an example shown here of home run results, and notice how you have here different intervals. And the big thing here, as you see, is all of these intervals don't overlap and they're all equal in size. If you think 2, 3, 4, 5, these are all intervals that have size of 4. So every 4 numbers without overlap, you've got an interval. And that's very important when you're making your frequency tables for the purposes of using them to create histograms. Now a histogram is going to be that graph that displays data from a frequency table. So I have here a frequency table about number of hours of watching television and the frequency table that matches. And notice we created this table with intervals of 0 to 5, 6 to 11, 12 to 17, 18 to 23, all this size of 6. And then the frequencies, and then matched it in 2 intervals. So notice how the frequency is always on this y-axis here. And the intervals are always going to be on the bottom here. And the big thing important is to not have overlap, because if this was 0 to 5 and 5 to 10, then if it was a 5, we wouldn't know where to place it. Now, when we talk about histograms, we need to be able to identify the shape of the histogram. And when we talk about shape of the histogram, you have them either being uniform, symmetric, or skewed. And uniform means that the bars are all around the same height. Not exactly the same height, but relatively the same. So the data is uniformly spread over every interval. Symmetric means that the bars can be reflected across the line. You could draw a line somewhere and fold the histogram in half, and you would have relatively the same pattern. Skewed, on the other hand, the bars are going to be taller on one side or the other, and shorter on the opposite side. Now, we're going to be working our focus, as you could probably already tell from your score sheet on your project, you're going to need to make a comparison histogram. And what that means is simply 2 histograms that are meshed together in the same set of axes. So it's kind of like a double bar graph, but it's a histogram because we're dealing with intervals. So let's first start by talking about how we identify the shape of a histogram and explaining what that means about the data. So here we have this graph, or this histogram, and you've got your equal intervals here, and we were just looking at this graph, and we've got our frequency over here. These are really more of guidelines, so I'm going to put all these up. If a graph is uniform, you're going to have the similar height bars, and it means the data is spread out evenly, which clearly it is not the case with this one. If we have a skewed graph, one side is taller and data is mostly on the lower high end. That is what we have here. We have a skewed graph, and I can tell that because if I look, we've got a lot of people on this end and not a lot of people on this end. So something that I could tell you about the data is that most people watch between 0 and 5 hours of TV. And it's as simple as that when you're talking about what it means about the data. Now the third one I haven't put up yet is that symmetric one, where it's going to be tall in the middle, shorter on the ends, and we talk about the data being normal, like a bell curve. And that's what we've got here on B. This one we know is symmetric, because if you notice, it's lower here, and we're high here in the middle. And we're looking at heights of black cherry trees. So if you remember looking at the bell curve, where the majority are going to fall within 2 standard deviations of that mean that falls right here, then what we can do is we can say in quotations, normal distribution. And I put normal in quotation marks because we're not saying that this is the way it should be to be quote unquote normal, but we're saying that the majority fall within the middle. And now if you notice, this is a slightly different view of a histogram. What this is saying is that because it doesn't have the interval written, is that this first bar here falls between 60 and less than 65. And this second bar falls between 65 and less than 70. And this another way to write it is much nicer to write it where you put the intervals like we had up here. But it is an option to use. Now this third one, this one is talking about the distribution of 1,000 random numbers between 0 and 1 being selected. This is what we call uniform. And the reason why is because if you would expect, as you know from using the random number generator, when you click that to generate random numbers, you should expect to see numbers spread out all over the board, which is why that this one is uniform. There is no one bar that is high, extremely high or extremely low. And so we would say that random numbers have an even distribution over the intervals. And I'm going to say over all intervals. Now the next video is going to start talking about how we can create these histograms and create these frequency tables.